Hello everybody and welcome back to our first lesson about the Numpy package. So in the last lessons we have seen that Python has limitations when it comes to large-scale numerical operations. Python is simply too slow for this, and therefore the Numpy package was created, and the roots go back to the year 1995, where it was developed under the name Numeric, and later in the year 2006 it was finally released as the Numpy package. Since then, Numpy is the first choice in Python when it comes to numerical computations and fast vectorized operations over large arrays. And we will see in the next lessons what I exactly mean with this. However, to give you an intuition, typically so in many tasks where we use the Numpy package, there is no further need for loops or if and else statements. So with Numpy we can reduce many lines of code and can also increase the performance of our code. And also Numpy is typically the number one choice for mathematical functions in general, and in particular for linear algebra and also for random number generation. Alright, so let's start coding, and before we can use Numpy we have to import Numpy with the keyword import Numpy, and then we say please use Numpy as with the abbreviation NP. So that's by convention. So most of the users use the convention or the abbreviation NP for Numpy. And then we create a list, so we already know lists, a list from 1 to 10 including. Here it is. And then we can transform the list into a so-called Numpy array. Numpy arrays, or also ND arrays, are fast and flexible container of large numerical datasets. And these arrays enable us to perform operations on whole blocks of data in a vectorized fashion. So we will see later what I exactly mean with this. But first of all, let's transform the list into a Numpy array with the function np.array. So now you can see, it looks similar to a list here actually, and here with the array word you can see that here it's a Numpy array. Earlier we learned that typically in Jupyter Notebook there's no need to use the print function. So we can print here the array by just executing the cell, and it gives the same information than with the print function. However, the way how the output is represented or formatted is sometimes different, and here this is the case. So if we explicitly use the print function, there we can see that the output is formatted in a different way, and here the array looks like a vector, and this is exactly how a Numpy array behaves later with the operations. So like a mathematical vector, so if you multiply a vector with a scalar, let's say 2, then element-wise each element will be multiplied by 2. And that was exactly the behavior that we didn't see with lists. With lists, if we multiply a list by 2, we just get 2 times the copy of the list concatenated. But we will go more into detail later in the next session. So now let's first check the data type of my array. And it's a Numpy ND array. So Numpy array or ND array, I mean the same with it. And same as lists, a Numpy array is a container of elements, so we can also iterate over a Numpy array. So for element in my array, I can print all elements, 1 to 10. And with lists, we have learned that lists can store many different elements, and from many different data types. So a list can store an integer and float, a string, and a Boolean object. So if we iterate over the elements of this list and print out the type of each element, so we can see that we get an integer and float and string and a Boolean object. So 1 is an integer, 2.5 is a float object, dog is a string object, and true is a Boolean object. So now we are coming to the first and one of the most important differences between a Numpy array and a list. So let's try to transform the list here into a Numpy array called A. And then let's try to iterate over the elements and print out the type of each element. And there we can see each element is a string. So we can see here also 1 is transformed into a string, 2.5 is now a string, and also true is a string. And a string is typically the least common denominator. So yeah, you can transform an integer or a float into a string. You can also transform a Boolean object into a string, but yeah, you cannot transform a string into any of the other data types. So the string is typically the lowest common denominator here. And yeah, that's a general rule that in a NumPy array you can only store one data type. And typically, and that's why NumPy is famous and successful, is that yeah, you typically use it with numerical data, so with integers and floats. And that's one of the reasons why NumPy arrays are much faster when it comes to numerical operations, because NumPy does not have to check which data types it contains. It knows, okay, I only have integers or floats, and I do not have to care about what data types I have. And yeah, that makes it more powerful and more faster in the numerical operations. Alright, to give you a better intuition, let's create a NumPy array B with 3 integers. So the type is still a NumPy array, and with the attribute dType we can check the single data type that B contains. So here it's an integer. And now when we transform one element here into a float object by just adding a dot, so here you can see that NumPy transforms all elements into a float object. And let's check it here. The data type of the NumPy array B is a float. And now if we transform 2 here into a string, there you can see that all elements are transformed into a string. Alright, so this is it for the time being. Yeah, we learned actually that a NumPy array contains only one data type, and that's one of the major differences to a list. And in the next lesson we learn about vectorized operations. This is another main difference to a list. So hope to see you in the next lesson. Bye!